Hello, guys. Um, welcome to my YouTube channel. Um, so, all right. So, um, so this is basically a redo of what I had done yesterday, but then due to my technical issues from yesterday, I could not um, have a good stream. So I decided to redo it again today, and I'll perfectly understand if people don't really join up today. Um, but based it's just a redo of what I had done yesterday, right? So um, so once again, I will just say welcome to today's stream. I'm so excited to go over this again with you guys. So we'll start with writing a Hello World program. So looking at my screen, I already set up my VS Code, a Rust boilerplate where we can start writing code from. So we'll go through through source codes step by step. So we'll start by writing a Hello World program, and then we'll go step by step and dive into some of Rust unique features along the way, right? Um, so that is that. So a we'll start with a basic Hello World program, right? So in Rust, we have kind of like, okay, guys, hold on. Let me. So okay, all right. So so let's go over what a simple Hello World program is, right? So looking at my screen, once you set up a Rust, work environment, you'd, you know, have a function and a main, and So you have a function, a main function, and you have like the print hello world, which is like the starting point of every Rust application. So the first thing we'll do is how we write comments in Rust. So it's similar to like other languages, right? It's similar to other languages. We have where we use the double slash. So we can say this is a comment, and that's like, a comment. Then if we want to have like multiple lines of comments, and we don't want to have like slash, we don't want to use slash multiple times, something like this, we can, instead of doing that, we can start it with a starting slash and end it with a starting slash and a star, and end it with a star and a slash, right? So that would add a comment for us, so something like this. So we can use this to have comments in multiple lines. So this is how these are the two ways in which we can add comments in Rust. And what this does is that the Rust compiler would just basically ignore these lines of code. So it's similar to like if you have previous programming experience, it's similar to like how you add comments in JavaScript or Python or C++ and other languages. So it's a very important something that we use in programming languages. Then we'll go over to writing a hello world in a Rust application. So now we have like a main function, which is kind of like is the entry point for every Rust application, right? So this is the entry point. Then we have the print line, which is the macro, which is used to print text to the console. It's kind of like similar to console.log in JavaScript, right? It's coming from a JavaScript background or Python. The way we use you print things to the console. It is very powerful and it is versatile, right? It is very versatile. So now, let's go ahead and compile this code, right? So one way you can compile code in Rust is using the we can compile code to binary using the using Rust C. So there's a command called Rust C. What I would do here is, because we are in the Rust by example folder, so we'll cd into the source folder. And now that we are in the source folder, if we check what's in that folder, we can see that we have the main.rs, which is this file. So now we can run a command, a Rust C. So we'll call it Rust C. So basically Rust compile, and we'll type in the name of that file. So we'll say main.rs. So if we do that, you will notice that a binary file was added to the root of the source folder. So if I try to open that file, you see that I can't even open it, but I will just go ahead and try to open it anyway. So you see, binary code, right? These are like, it has been compiled into jargons that we cannot read, basically what the computer can read, right? So now, in order for us to be able to get our hello world from here, the only thing we can do now is just to do ./main.rs. Okay. Permission denied. That's weird. So main.rs. Sorry. Okay. So I'm getting permission denied. Maybe I have to do some permissions but basically, in order for us to be able to run to get hello world printed to the terminal, I know for a fact that I've done this before. I don't know why it's not working now. And we have to run main. I think it's main. Okay, yeah. So main. I was doing main.rs. So we have to run main, which is the name of this file. And sorry, the name of the binary file, exactly. I was running main.rs instead of the name of the binary file. And we'll be able to print hello world. So we've successfully compiled our first Rust code into binary code that we can now print to the terminal. So we can go ahead and make this more interesting by adding another line of code. So we can say print line, and here we say I am a Rust guy. Yeah, so save this, and once again we'll build the code rust c.main, and once again we'll then go ahead and run it, and you see we have I am a Rust guy, and the hello world printed to the terminal, right? So now we'll go over to formatting. So Rust provides a very powerful way of formatting, and a very powerful formatting system through macros like the print line. Like initially I mentioned that this is a macro, so the print line is a macro in Rust. Subsequently, as we go on in our Rust series, we'll get to the point where I explain what macros are in Rust. But for now, it is kind of still far away for us to talk about. So back to what I was saying, I said Rust provides a powerful formatting system through macros like the print line that we use to print, to the console. So here are some examples of how, we can use the print line itself. So there are several examples. I will just go ahead and paste them here and explain. So the first one, and this is coming directly from the documentation, right? So in case you are curious, you can always, head for the documentation. So this is another example of how we can use the print line, right? So now we have 0, this is 1, full stop 1, this is 0. And after that, we have Alice and Bob. So I want you to take a close look at what we have in our string here. So we have certain values in our string. So I'll call these the arguments, and sorry, these are our arguments, and these are what we are trying to format into these are the things that we are trying to format into our string. So what is happening here is that we are using the index, right? So we have 0 and we have 1. So we have Alice, who is at index of 0, which is the first one, and we have Bob, who is at index of 1. So if I go ahead and I build the binary and run this code, you'll be able to see that we'll have Alice, this is Bob, Bob, this is Alice. So if I do that, I'll just quickly rust C, and then I'll run code. As you can see, we have Alice, this is Bob, Bob, this is Alice. So what is happening here is it is using the index, right? We know that in programming things are 0 index. So using the index to kind of, replace, kind of format what we have here. So if I can go ahead and edit this and say, for instance, I'll add, let me say my name. So say, add my name as the third value here, which would have the index of 2. I'll say I will now go ahead and say, and welcome at 2. So I'm saying, so basically what we're saying here is Alice, this is Bob, Bob, this is Alice, and welcome Chinedu. So I'll go ahead and build the binary again, and I'll run it again. Okay, I didn't save, so I didn't save this file, so I'll go ahead and save it. Also save this and run it again, build the binary, and so before I run it, I'll just clear. Yeah, so as you can see, we have Alice, this is Bob, Bob, this is Alice, and welcome Chinedu. So next we are going to talk about the debug and display traits. So Rust has 2 main traits for formatting. So we have the debug for debugging output, and the display for user-friendly output. So there's something called a derived debug, right? It enables us to be able to log things like structs, which are structures, to the terminal. So I would quickly write out some code. So I'll comment this out, or I'll just leave that in. So at the top here, we would create a struct. So structs are kind of like how we create objects in other languages. So I'll say this is struct person, and in this person we have the name and reference. Okay, static slice, static string slice, str. Then we have the age, which is a type of U38 or U8, sorry. And we have our struct, right? Now, since we already have our structs, I will just comment out these lines of code. Remember that the main function is the entry point for our application, so everything has to, be in the main function. Like if you want to print something or that, everything has to end here in this guy. So now, here I am going to. Oh, sorry, I don't know what's happening. All right. So here, I think that's some AI stuff. So here in the main function, I have a person, right? Now I have to pass value to the person struct or use it one way or the other. So I will say let's Paul, let me just use small letter. Let's Paul be equals to person. So in that person, I am now going to pass the brackets, and as the person's name, I'll call the person Paul. I'm going to pass his age. So his age, I'm going to say he is 38 years old, sadly. And I'm going to close that up. So now we have Paul, so we are using this struct, right? So now let's try and print Paul to the terminal and see what would happen. So print line, and we'll just pass something like this, and this should give us an error message, and I'll explain why that would happen. If I save this, and so we can already see, right? So person doesn't implement the debug traits, right? So it is not implemented, and this is one of the nice things about Rust. It's the compiler exactly gives us meaningful error messages to kind of guide us in what we are doing, right? So now, and we can already see that we are having like an error there because we've not passed in the, we are not implementing the debug trait on the struct. So what it does is, it helps us to print, our struct to the terminal. So now, in order to resolve that issue, we have to add a derived debug on top of the struct itself. So here at the top, I would add a derive. So derive, and then I'll put a debug. So that should hopefully fix our problem. Okay. String static. I'll just make this a simple string. Doesn't matter. Derive debug. All right. So now we no longer have that error. So I can go ahead and build this code and run it again. So I'll build this. We'll just ignore the error messages for now. Come back to that. So these are just warning messages, not like really error messages. Come back to that. So now I will then go ahead and run the code. So I should be able to see exactly. So I can now log this to the terminal, and this is because of the derived debug traits that I added on top of the struct itself, right? So there is another way of printing, or printing something that is more beautiful, making it look more clean, and that would mean us. So I'll just duplicate that, and I'll do cargo fmt to format the code, and then save. All right. Okay. run that code again. Exactly. So I formatted the code such a way that it looks clean and nice. So we'll still talk about what cargo does for us in in Rust. But for now, I just want to like do a more beautiful print to the terminal, something better than what we have here. So in order to achieve that, I'll add hash to this, and I would build this again. And guys, we will not always build from scratch like this, right? There is a wonderful way to do these things that is very easy using cargo. But just for the sake of learning, I will be sticking to building it and running it directly from the binary file. So now I'll say Rust C main. I'll build that. Clear. Don't mind the warnings. Then I would run the main file again. And exactly, so you can see how clean and beautiful it is here, and compared to the first one that we had. So next, we are now going to talk about. So this is for the debug traits, right? So this is the derived debug trait. So next, we are now going to talk about the display. So because if you remember, I said Rust has two main traits for formatting. We have the debug for debugging output and display for user-friendly output. So now let's go over to the user-friendly output. So in order to do that, I will just comment out a couple of things that I have here. First of all, or I will just add a new struct. So I'll say struct, and I'll call it structure, and I'll pass, it should be an i32. And this type of i32 should take a type of i32. Then I will implement on it. So impl, and okay, so for structure, and okay, so there would have a function fmt dot display for structure, and so there would have a function, and this function would fmt, and we call it fmt, and it will take some certain things. So it will take self, it will take not a function, is like more like a method, right? So it will take self, and it will take f. So I will address what those things are. So then to take a reference, a mutable reference, and the fmt on the formatter. So we'll return we'll return a result. And there we'll just do like a write. So write if, so a write macro, and in that we'll have our if, sorry, not if, f, pass in curly braces, which and we'll pass our self dots 0 self sel f there, which is the number, which is i32. So now we have this here. We then have to import what's it called, the fmt from the from the standard formatting library. So we would say here we have use std from fmt. Exactly. Nice. So now we'll then go ahead and print to the terminal to see what would happen. So I'll cut this and paste it under here. Now then save, and then cargo fmt, format everything. Then I'll comment this out, and I would print for the other one under here. So I'll just say print line, and I'll pass in my empty objects and then the structure. So I'll call the structure struct, which I had created, and I'll pass a number to it. So I'll pass a number. So let's say I pass 30. I close the bracket and I save. So now let me take this down. So here I can then run. So I'll clear, save this first. Then I'll build the binary. Exactly. I'll clear it again and then run the file. Exactly. So now we have 30, right, printed to the terminal. So the display trait requires, manual implementation. The difference between the display and the derived debug is that the display gives you complete control over how your types are displayed, right? So that's that for like the introduction to Rust, like Hello World and all that. So guys, don't really pay attention to all most of this code. The most important thing here to take note of is the entry point for every application is the main function, right? How you print things to the terminal, as it is with other languages, you use the print line macro, right? When you want to, print something to the terminal, and it has to do with a structure, how we kind of like set objects in other languages. You have to derive debug, right? Then you have traits. So there are two traits that are implemented in the form in the formatting, or when it comes to Rust. And those two traits are the display and the debug traits. So as we go on, would talk more about some of these things I'm talking about. Like for instance, traits, what traits are, what an implementation block is, what kind of function this is. It an associated function? Is it a method? Why we are doing what we are doing, and all that. But for now, I just want to focus on the introduction, the basics of the language. So next, we are now going to talk about Rust, like Rust primitives. So we have like literals, tuples, arrays, and slice, right? So now Rust provides a wide range of wide variety of primitives. So we'll look at a couple of them, right? We'll look at a couple of them. But first off, they are divided into two major classes. We have the scalar types and we have the compound types, right? So now the scalar types are where we have the signed and unsigned integer. We have, so what these signed and unsigned integers are, like numbers, right? So numbers, they have the signed and the unsigned ones. We have floating numbers, like floats. We have the F32s and the F64s. We have character type, which is a CHAR Unicode, and it represents a single character. So A, small letter A or capital letter A, which each of them have like 4 bytes, right, in the memory of our computers. And we have like booleans, which which is always true or false. Then we have the unit type, which is an empty parenthesis. So this is kind of similar to what we already know from other languages. If you're coming from a previous language, maybe JavaScript, Python, C# or something, it's still the same knowledge, right? It's still the same thing that you've always known in all those languages. So what I'm going to do now is I'm just going to add comments, and those comments I'm going to then like use them to walk us through what I had just explained. So I will have like a kind of a visual representation of the scalar primitive types in Rust. So I'll quickly paste them in my VS Code. So I'll add a comment. So we have this. So these are I'll say these are primitives in Rust. Guys, please, if you can hear me, please say hello in the chat so that I'll be sure that I'm not speaking to myself. Guys, if you can hear me. So while I wait for you guys to maybe say something, hopefully um I will just go on. So now, looking at what's okay, thank you. So looking at what I had just said, we have you know two types of primitives in Rust. We have the compound and the scalar. So looking at the scalar, this scalar just represents numbers, right? So we have signed integers. So integers are numbers. We have signed and unsigned, and we have about five different types of sorry, six different types, right? We have the I8, the I16s, the I32, and the I64, the I28, and the I size pointer size, right? Then we have the unsigned integers, which is the U8s, the U16s, the U32s, and so on and so forth, as you can see here, right, on this second line. But by default, once you create a variable. So for instance, let's say I create a variable. Let's say let num be equals to 30, right? So once I do this, it automatically has a type of I32. As you can see, my VS Code is already suggesting to me that it is a type of I32. So this is automatically appended, right? So it has a type of I32 by default. All integers in Rust has a type of I32. I can actually change the type by annotating, or by adding a suffix, by adding a suffix to this number. So if I want this to become something like let's say an I8, I can just put I8 at the end, and you see that it automatically changed to an I8 there, right? Another way again I can do it if I don't want to do that suffix pattern is I can manually equate it and say this is a U128, right? And automatically it becomes a U128, right? So there are several ways in which we can, they can do this. I usually prefer doing the suffix where I just add it at the end and it's appended. So I feel it's kind of nice and easy to do that way. So without wasting much time, we'll move over to the next one, which are floating inputs. So we have two types of floating inputs in Rust. We have the F32 and the F64, as I mentioned earlier. Then we have the character type. So these types are, they represent things like, a single alphabets and all that. I think emojis too are part of it. I'm not really sure, but I think emojis are also part of it. Then we have the Boolean type, which is true or false. Then we also have the unit type, which is parentheses. So although the unit type is, typically in most cases a tuple, it is not considered a compound type since it does not contain multiple values. So with that, we'll go over to compound types. So compound types are like values that can, or let's say primitives that can contain, that can take in things, right? An example of these are arrays or tuples, right? So for instance, so I will just quickly add a comment for compound types. So we have arrays. So we have arrays, and arrays can only take one certain type. You cannot take, like, you cannot have one and a boolean in an array. So it must be either 1, 2, 3, right? You cannot have 1, 2, 3 and you now have something like true in an array, but that's a topic for another day. So this is an array. Then we have a tuple. So the tuple now does more than the array. So we have tuples, and this tuple is declared with parentheses, so you can add 1 and then you can add something like true to it. So like I mentioned before, right, variable can always be annotated, and numbers may, include suffix annotation by default. So by default, integers are I32 as I've mentioned, and floats, right, are F64. So let's now look at some examples. Let's quickly look at some examples. So here, I would say let's logic be equal to true, right? So initially, I remember I said that values can be type annotated. So I can manually, just like I had stated before, enter the bool value here, right? I can manually do that and just say it's a boolean. So this is like, my own annotation. Then we have like default annotation, but that aside, so we can also do for an F64. So if we do let's float, we'll call it float, be equal to 1.0. So you can already see that the moment I added a point there, we already have an F64 that is being suggested to me by my Rust Analyzer plugin that I have on VS Code. So I have 1.1 point. If I remove the point, it goes to an I32. So I can say 1.9. So we already know that that is a boolean. And by default, as I mentioned earlier, booleans are type of F64 by default, right? I can go ahead and add a suffix annotation to it. I can say, let me have another float. I'll just call it let's float 2 be equals to 1.2, and I would say it is an F32. And you can automatically see that it has changed this from the default F64 to an F32, right? So same thing can happen for a signed and an unsigned integer. Another thing again to note is mutable variables in Rust can change, right? So for instance, we can have, but let me not really go into that because I don't want to go out of the scope of what we are talking about. But let's quickly look at how to create arrays and tuples, right? So let's say let's my array equals to I would allow Rust Analyzer, or I will not do that. I would add it myself. So I would say I want it to my array to have an I types of I32, and I want 3 of them. So I would say equal to 1, 2, 3, right? Then I'll close it. So and if I print this, if I should print this, I'll get 1, 2, 3 in my terminal. I can still duplicate this, or I can go ahead and say let's my array 2 be equal to can say 1, 2, 3, 4. So as you can see, I have like Rust Analyzer already suggesting it for me. So Rust Analyzer is saying that I have types of I32s inside my array, and I have 4 of those values in that array, right? If I go ahead and add something that is not an I32, it would break. So if I add something like true, okay, let me see. Exactly. So I get an error saying an integer but found a boolean. So arrays cannot take different types. They can take only one type. They cannot take different types. They can take only one type at a time, like I mentioned before. So if we wanted to have only booleans in this array, we'd have to change the I32 here. We'll have to change it to a bool. So we'll say it's a bool, and we'll have to remove all these integers, right? Remove all these integers and save. Okay, and we'll remove the value of 5 because it's only one that we have there. So I'll add 1 and save. Exactly. So just ignore the unused variable. So it's a Rust thing, and I think a Rust Analyzer thing where Rust tells you, in fact, it gives you errors for everything just to guide you so that you don't make mistakes and write a bunch of dead codes that you're not using. There's something called dead code that I could actually add at the top that would prevent all this from happening, but I'm not going to. I'm just going to leave it for the purpose of learning. But the idea here is that by an array can take only one type, right? If it can either take integers, booleans, floating types, or what other one do we have on that? Character types, right? And the character types include like a single alphabet, things like an emoji, an emoji. I'm sure I'm not really sure of that, but I will test it out. I know that it can take only single character. So a character type is A as a single alphabet, right? So I will just quickly undo this and go back to what we had before. Undo, save. Exactly. Then moving forward, we'll then display a tuple. So how do we create a tuple in Rust? So say let's my underscore tuple. So in case you are coming from a different programming language and you're used to like JavaScript's camel casing, and you will notice that I'm not doing that in this case, right? Maybe some other languages have like camel casing, some have Pascal casing. In Rust, we use something called snake case, right? In fact, it is a convention, and I know that based on experience or something, I've seen situations whereby I tried to use camel casing and I had like a warning from the compiler, right, asking me or telling me to stick to the convention, to the convention. So what I mean by this is, if I, for instance, if I do something like this, let's say my tuple, tuple, and I say equal to, I have equal to, I'm sorry, let me say 1 true and 1.3, right? So you can already see that my Rust analyzer is already underlining this, right? It's saying a couple of things. You can see that it says variable my tuple should have a snake case type. So it is not really an error. It's kind of like a warning, right? In order for us to stick to the convention in the language. So it will just give you that error, that message, warning you, telling you that you should switch to a snake case. I will do that, but before I do that, you can notice that in our tuple we have different types. If you remember, I said an array in Rust cannot take more than one type, but a tuple can take multiple types, right? If I hover over my array, you will see that here we have an array, and in that array we have an i32s, and there are 4 of them, 4 values, right? So we have 1, 2, 3, 4. There are 4 of them, 4 of these guys. If I pass a different type into that array, I'll get an error. But that is not the case for a tuple. A tuple in this case, as you can see here, my tuple has a type of i32, which is a number, a boolean, which is true that I've added here, and an F64, right? It has an F64. Let me hover again. Yeah, which is the floating value, which is 1.3, right? So I'll quickly go ahead and remove this, change it back to snake case. Exactly. And then just to take away all these errors, I would comment out these lines, and then I would print the rest. I'll print the rest. So I will just add a print statement here, print line, and there's no need for that. Let me just comment this out. No need for that long process. But basically, here you can see that we have an i32, a boolean, and an F64. And this is just Rust Analyzer showing me the values I have. I can manually enter this myself, right? Or I can just double click on this to insert it. So, it's an extra added feature that comes with the Rust Analyzer. So I can just double click it and it will automatically add it for me, something I can still do by myself. There is still another way we can do this, right? I can come here and say, let me declare on that tuple. So I'll call this my tuple underscore 2. And I'll just say equal to, I'll enter my values. So now I said something about suffix annotation, right? We did something like that here on line 21, right? Where we added a boolean, a floating value, which is 1.3, and we added a suffix, the type, to the end of it. So we said F32, right? So as you can see here, this is a suffix and it would automatically define the type for the floating value. So that's similar to what I want to do here. So I'll enter an integer. I'll say 10, and I'll give it a type of I8, right? If you remember, I said there are different types of signed integers. So there are two types of signed integers, two types of integers. We have the signed and the unsigned integer. So in the signed integer, we have an I8, we have I16, we have the default, which is the I32, I64, I128, and the I size, right? Then we have the unsigned ones, which is the U8, U16s, U32, and so on and so forth. In our later streams, I will really go deep into why we have different integers, and why we have signed and unsigned integers in Rust. So now when I've added the type of I8, you can already see that my Rust analyzer is already taking it there to be the type, right? The primitive type, the type for that value. So I can go ahead again and add something like, let me say minus 5.04845, and I will say is a type of F32, right? So I have to add the closing bracket. So you can now see that it has taken it as an F32. If you remember, integers in Rust are by default I32s, and floats in Rust are by default F64, right? So what I've done here is I've used suffix to kind of change their default value. If I should remove the I8 at the end of 10 and I save, you would see that it will automatically change to an I32. It's no longer an I8 here. If I undo it, it goes back to an I8. Same thing happens here. If I take out the F32 and I save, it changes to an F64, which is the default. If I undo it, it comes back to the F32, which is the default. So once again, just a recap of everything I've said. We have two different types in Rust, right? We have primitive types in Rust. We have the scalar types and the compound type. In the scalar type, we have signed and unsigned integers, we have floats, we have characters, and we have boolean, and we have units. While in the compound type, we have arrays and tuples. So I not spell this well. Okay, tuples. So now let's talk about literals and operators. So Rust supports a wide range of literals, including integers, floats, characters, string, booleans, and unit type. A number can use, hexadecimal, something like OX, and octal, something like O alphabet O, that is 0 and alphabet O, or binary, something like 0 and B prefixes, right? We can also use something like underscore for better readability, right? So for instance, let's say we want to write a number. I think this is where I will need my print again. So let's say we want to write like 10 million or something like that, right? So I will just enter this thing and I will say millions, and I would declare a variable here. I'll say let my millions, let it be equal to, let's say 1 0 0. So this will be 100, this is 1,000, 10,000, 100,000, 1 million, right? You can already see that this is kind of difficult to read, right? It will be difficult for someone to read, right? So what I can do now is I can add underscore to make this thing more readable. So I can add an underscore here and add another one here to make it more readable. And when I run this code, so I will just quickly run the binary again, and then I'll clear everything. Then I'll run the file. You can immediately see that Rust automatically ignored the underscores that we had here, right? You can see that we logged our millions here just to prove that this is actually what we logged. So I'll just add a value here. I'll call it millions, and I'll add this. Then so something like this, and I'll run it again. clear everything. And I'll run the file. So you can see, right, it is that line. So this is millions, right? You can see that the compiler ignored the underscore, enabling us to have like better readability and all that. So now let's talk a little bit about tuples. A tuple is a collection of values, as I've explained before, that takes in different values, different types, right? And it uses a parenthesis, just like we've seen here. So I'll go ahead and log a couple of these tuples just to show them in the terminal. So I'll remove this guy. I'll just pass this. I'll call it tuple. Save. Now clear this. I'll run the main file. Exactly. So we have our tuple here, and we have the value of 10, which is an I8, and minus 4.04 in it, right? So that's basically all we need to know about tuples. There are a couple of examples I could go into, but for the sake of time, I don't want this stream to be excessively long. I wouldn't be really going deep into that. So let's briefly once again talk about arrays. So arrays, like I said before, stores elements of the same type, and are defined with the the value itself and the length, the number of values that will be in it. So the type and the number of values that will be in it. Then we also have something we call slice. So that slice, on the other hand, are dynamically sized view into an array. An example of what a slice is, so for instance, let's say we have our array. So I would comment out everything that has to do with everything that is a tuple. And here now we have our array, right? Let's say we want to be able to see some certain values in our array, right? We want to be able to view some certain values. We want to be able to view everything. So for instance, my array 2, so the second line 24, so I'll comment out line 23. Let's say we want to see my array 2, right? How do we do that? So what we can do in this case is we can do something that is called borrowing of a slice, right? I'm not going to explain too much, but I'm going to just show you guys what I mean by this. So now I'll go ahead and call this an array, and I'll copy this and paste it here and save, and first of all run. So guys, I say a cleaner way of, instead of always building the code, there's a way we can use cargo run to run our code. But in our next stream, I will be talking about that. So here, what I will do, I will just go ahead and build the binary code and run it again. So I have like my arrays, right? So what happens if I want to slice from that array, right? I can immediately define another function. I can call it analyze slice. And what this, it will take a certain number and it would print to the console for us. So for instance, I'll say fn analyze underscore slice. So this will take a slice, takes a slice, and it will take a reference to that slice. So the references are another thing we'll talk about later on. An array of I32s, so we have to specify that's what we are sending. Then in that place, we'll now have a print. So I'll just copy this and paste instead of spending time writing it manually. Paste this here, and I'll save my cargo fnt format. That is, so I have my analyze. So now we already have our array is defined here, right? So what I will do now is, let me now borrow my slice, right? So I'll call the analyze slice, and this analyze slice is expecting to take something. So I'm going to pass it a reference. So first of all, references are denoted with the and symbol. So reference to my array. So I'll call it my array to this. And in it, I would say I want to get values from 1 to 3. Right. So I'll save this. Oh my god, what have I done? Okay. So I'll save this, and at the closing, this is have I done underscore. Okay, so I'll add this, save. Okay, here I will then say I've added a reference to my array, then I'll say 1, give me 3, save. So I'll build the code again, clear everything, and let's see what we get. So you can see that what we got here is we got the first element, which is the index of 0. We got first element is 2, right? So the first element is 2. And why is that the case? This is the case because we are picking from the index of 1 to the index of 3, right? So now what we are doing is we are sending to our analyzed function is 2 and 3. If you doubt this, I can go ahead and just log slice directly here. So I can, instead of logging the index, so instead of logging the first value in the slice, I'll remove this and log the index. So if I should, doesn't implement an i32. Oh, okay, I see. Okay, so I will just, I'll say S1, and also implement another one for the second element. So I'll say second element. I'll pass 1 here. Save. Build the code, and then I'll run the binary file. So you can immediately see that we have 2 values there, because from what we did here, we are passing a slice, right? We are passing the values on the index of 1 to the index of 3, right? So we are getting 2 and 3, and we are passing it into our analysis function. And this our analysis function is then printing it to the console, including the length. So the length is, we have length of 2. So there are 2 elements in that array that we sliced. In case you are wondering, a situation whereby we want to get the first element. If we want to get the first element, we'll start from the index of 0. So an example of this would be, let me change this from 3 to 2 and change this from 1 to 0. If I save, you'll see that what we would get in the terminal will now be 1, right? 1 and 2. So I will just go ahead, or let me just leave it at 3. So the length will change to 3. So I will leave it at 3, save, and then I would build the binary again, and I'll run the file. Exactly. So you can immediately see that we have, the first element, which is 1, because now we're starting at index of 0, which is here, and the second element, which is 2, right? Second element is 2 because that's at the index of 1. Then the length of the slice that we are passing into this analyze function is actually 3. So guys, I think this is basically an intro to Rust, how the entrance into a Rust program, how to write a Hello World code in Rust, the entry point into a Rust application, which I mentioned earlier, that is the main itself, how to use suffix type annotation, and prefix type annotation and all that. We also learned about tuples and arrays. Also learned about different primitives, the two types of primitives in Rust, which is scalar types and compound types. And we went deep into the scalar types, which are the signed, unsigned, floating points, and all that. We also looked at the derived debug aspect of printing a struct to the terminal, and how it helps us print really nice code to the terminal. We also looked at the traits, the display traits also, and the manual control it gives us when we are trying to log things to the terminal. So guys, I would say thank you so much for joining me on this live stream. Yesterday's live stream was a major flop due to issues I had with my mic, and it took me over 24 minutes or 25 minutes to figure it out. But I'm glad that I still had some people here, even if it's one person, even if I'm the one talking to myself, right? It is still something at the end of the day. So I just want to say thank you so much for joining me on this one. These kinds of contents are what I would be doing a lot this time around, because I find it really easy to just come and talk about things rather than recording and editing, spending time editing all those things. So another aspect of or the kind of videos that you guys might be seeing from me soon would have to do with embedded Rust. So and what embedded Rust means is writing code that runs in hardware. So if you can see my hand, this is, I don't know, my camera is so bad. It's laptop camera. Anyways, these are hardware devices. So this is an STM32 discovery board. You can use this to do a lot of things, automations. You can use this to turn on your light bulb. You can use this to, just basic smart home devices, right? Smart devices. So if you want to clap and you want the music to play, you want to something, just automate your life, basically. You do them with these boards. I have about 3 of them, 3 different ones. I have another one, which is an STM32 board. This one is somehow covered with a casing. I covered it with a casing, and since then I've not been able to remove it. But this one is quite beautiful and less intimidating. I'll be making videos like this with time, and I get more comfortable with the whole streaming stuff. I'll start making videos, building interesting projects or doing interesting things with this type of boards, right? So without rambling so much, I just want to say thank you so much for joining me on this video. And within the week, I'll also stream again, and it will be basically focused on data structures and algorithms. I think I'll be doing it possibly Tuesdays or Thursdays, where I will just come and implement a DSA and just use it as a form of learning for both myself and for you guys and anybody that is interested. So once again, thank you so much for joining me on this one, and I will see you in the next one. Bye.